Hey guys, so this is your video lesson on density, and I'm going to go through a couple of ways to explain to you the characteristic property of density, and hopefully by the end you love density. Alright, so just a couple of things to recap from your prior knowledge. That is the difference between mass and volume, because these are the essential components of density. Mass, you remember, is just the looking at the amount of matter that an object takes up. Um, and that unit for mass is always in grams. Sometimes it could be kilograms, but we primarily use grams. Volume is again the amount of space that that object is taking up, and volume could be in either milliliters or centimeters cubed. It really could be in liters as well, but these are the most common ones. Well, for our purposes of our lessons, we're going to use centimeters cubed, and remember that they're equal. 1 milliliter is the same thing as 1 centimeters cubed. Okay, so a couple of things to move on. Um, you've got one way of looking at density with this heart, and so we're going to look at mass, and we're going to put volume at the bottom. And this is the formula for density. Density is equal to mass divided by volume. And the purpose with the heart is to say that density is something that you love so much that if you cut it in half, you would have twice as much. And that's to say that if we increase the volume by double the amount, we would essentially be dividing by that larger number now, double the amount, and then that would increase our numerator, right? That would increase the amount of mass. So we'd have, of course, we would have more mass of that object. Okay, that's one way to look at it. Another way to look at it is with good old algebraic equations. And if we look at density is equal to mass over volume, right? That's our original equation. And if I asked you to manipulate that, therefore, and solve for, let's say, mass, mass would equal volume or, or density times volume, right? Because we would be multiplying by volume on each side. Or if I asked you to solve for volume, volume would be equal to simply dividing by density on both sides, the amount of mass divided by density, right? So those are three different ways of solving for each of the variables in the density equation. Well, you have also what's called this density triangle, or really this works for any algebraic equation with three variables, okay? And the way this works is you set up the triangle just like I did here. We're going to put density at the bottom left, mass on the top, volume at the bottom right, and you cover up the variable that you're trying to solve for. So if we're trying to solve for density, then ding, 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 here's our equation. Density, we're covering it up, is mass over volume, right? Same equation up here. If we were then trying to solve for mass, ding, 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 mass is density times volume, right? There it is, same thing. And of course, if we were trying to cover up and solve for volume, volume is mass over density. So it's the same way of getting to the same solution. It's just however you prefer. The trick again is just to make sure you set it up correctly. So what I always tell my students is that when you're going to go get your driver's license someday, you're going to go to the Division of Motor Vehicles. And this is what we call the DMV. You think of the density mass volume equation. So the DMV, you're going to get your license. And we're going to start clockwise, starting at the bottom left, DMV, right? So hopefully that helps you to remember density equals mass over volume and the whole density equation. Okay, so make sure you're really getting all of this. I'm gonna have a little reveal here. What makes up density? Of course, we have mass and volume. And how do you put those two together to get the formula for density? Right, mass divided by volume equals density. Good. This little slide here, I'm not going to go through it in the video because I'm actually going to pull this up in class, but this is just a fun little way to check and see that you understand the difference between mass and volume and what would go where. And this is just a way to take the objects and draw them into their appropriate vortex and watch them disappear. But we'll do that in class, so we'll have fun for that in class. Look out for that one coming up. All right, let's go into some practice. So calculate the density of the box using the formula below. Of course, we know the formula. Again, density would equal mass over volume. So in this case, we have that the mass of the box is 26 grams. All right, so we're going to do density. The mass of the box is 26 grams. And the volume of that box is 32 centimeters cubed. Okay, and if we divide that out, we calculate that out, then just do that in your calculator and go to two decimal places. So we'll go to two decimal places. It would actually come out to 0.81 grams per centimeters cubed. Okay, and that would be your final answer for density. That's it. Done. All right, let's try another one. All right, calculate the density for this box, this problem, given that the mass is 21 grams, the volume would be 28 grams. Here again, density would equal mass divided by volume. I want you guys to figure this one out, solve it, bring it to me in class. I know you watched the video. So we've got 21 grams divided by 28 centimeters cubed. And you tell me, what does that equal? We'll be looking for that. All right, and let's just look at one more, and you can pause this one if you need to. We're going to again set this one up. Given the mass of 26 grams, a volume of 32 centimeters cubed, what would we get for a density? Pause it, figure it out. Did you get 0.75 grams per centimeters cubed? I sure hope you did. All right, so that is it in your density lesson. I hope you enjoyed it and understand density. See you in class.